What if I told you that not all atoms of the same element are exactly the same? Some are a little heavier, while some are lighter, yet they behave almost the same way. These special versions of atoms are called isotopes. And today, we are going to understand them step by step, from the ground up. To understand isotopes, we first need to understand atoms. Every atom is made of three building blocks: protons, which have a positive charge, neutrons, which have no charge, and electrons, which have a negative charge. The protons and neutrons live in the nucleus at the center of the atom, while the electrons move around that nucleus. There is one important rule. The number of protons defines the element. For example, hydrogen always has one proton, carbon always has 6 protons, and oxygen always has 8 protons. If the number of protons changes, the element changes. But what if only the neutrons change? That is exactly where isotopes come in. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. Because neutrons add mass, isotopes have different masses, even though they remain the same element. In one sentence, isotopes are atoms of the same element with different mass numbers due to different numbers of neutrons. Let's look at hydrogen, the simplest element. All hydrogen atoms have one proton, but they can have different neutron counts. Protium has 0 neutrons and is the most common form. Deuterium has 1 neutron, making it heavier than normal hydrogen. Finally, tritium has 2 neutrons and is radioactive. They are the same element and have the same chemistry, but they have different masses. Now let's look at carbon, an element essential for life. All carbon atoms have 6 protons. Carbon-12 has 6 neutrons, carbon-13 has 7, and carbon-14 has 8. Carbon-14 is especially important because scientists use it for carbon dating to determine the age of ancient objects. You might wonder why isotopes behave almost the same chemically if they have different masses. The answer lies in the electrons. Chemical behavior depends on the number and arrangement of electrons. Since isotopes have the same number of protons, they also have the same number of electrons, meaning they react almost the same way in chemical reactions. Let's summarize. Elements are defined by protons. Isotopes have the same protons but different neutrons. This difference in neutrons leads to different mass numbers, but the same number of electrons ensures similar chemical behavior. Here is a quick check. If two atoms both have 8 protons but different numbers of neutrons, they are isotopes of oxygen. Isotopes help us understand atomic mass, radioactive dating, medical imaging, and even the history of life on Earth. Once you understand isotopes, the periodic table starts to make a lot more sense.